functions, and it is on page 455. If you've been following the lessons before, we've been looking at the relationship between two quantities, usually x and y, and we can represent that in words or a mapping diagram, table of values, equation, set of ordered pairs, or a graph. And these are all relations, and all relations have a domain, which is all the values of x that go in, and they also have a range, which is all the values of y. But today we're looking at a special kind of relation called a function. And there are certain criteria for it to be considered an actual function. To examine what a function is, we're going to look at two different relations. One of the relations can be expressed in words, is a multiple of. So when we look at the mapping diagram, you see that here's your domain, here's your range. And 1 is a multiple of 1. 4 is a multiple of 1. It's also a multiple of 2. 9 is a multiple of 1. It's not a multiple of 2. It is a multiple of 3. And 16 is a multiple of 1 and 2 and 4. So there's an awful lot of arrows here for the multiple of. And on this side, we have a relation called is the square of. So 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and 16 is the square of 4. So this relation is a little bit simpler. Each relation, we can write a set of ordered pairs, like 1 maps to 1, 4 maps to 1, 4 also maps to 2, so we'll add that to the list. 9 maps to 1, 9 maps to 3, and 16 actually maps to 2, 1, and also 4. So if you look at the number of arrows here, that's the same number of ordered pairs that are down here. This one's a little bit simpler. 1 maps to 1, 4 maps to 2, 9 maps to 3, and 16 maps to 4. So this relation only has 4 points in it. If we plot the points here, you can see that the blue function has way more points, and the red function only has 4 points in it. But the important thing I want you to note from the blue function is that if you look up a value of x, let's say the value of x4, you can see that the value of x4 has two different outputs. It spawns the value y of 1 and y2. If you look up x is 9, it also spawns two values, 1 and 3. And if you look up the input 16, it spawns three different outputs, 1, 2, and 4. But if you look at the red graph over here, any value of x you look up is only going to spawn one output. And that is the key to understanding why this is not a function, but this is a function. So the definition of a function over here is a function is a special type of relation in which each element of the domain is related to exactly one element of the range. Another way to explain that is if you put an x value in, it only gives you one y value out. So if any element of the domain is related to more than one element of the range, then the relation is not a function. So that's quite wordy, and it's a bit hard to understand, so we're going to do a couple of examples as to what this might look like. If you have an arrow diagram or a mapping diagram, and you have your x values here, and your y values here, you might have a function where the number 1 maps to the number 2. And maybe if you have the number 3, it maps to the number 4. This is a function because if you put in 1, you're only going to get out 2. So that's a function. But if you were to change it so that you have the number 1 and it actually maps to two different things over here, the number 2 and the number 3, this over here is not a function because if you put 1 into the machine, it gives you out two values. Interestingly though, if you have a mapping diagram where you have the number 1 and the number 2, and both of them map to the number 3, this is still okay. This is still a function. Because if you put in an x value of 1, you're only going to get 3. There's only one value. And if you put in an x value of 2, again, you're only going to get one value, the value of 3. Now, all of a sudden, if you add in something like this, and the number 1 also maps to 4, then it is no longer a function anymore. So what does this look like in terms of ordered pairs? So if you have 1, comma 2 and 3, comma 4, this is obviously a function because the number 1 only maps to 2 and the number 3 only maps to 4. But if you have duplicates of your x values mapping to different y values, this is not a function anymore. And again, it is okay for you to have the same y value twice. Sorry. It is okay for you to have the same y value twice, so long as it's a different x value that maps to it. So this is still okay. What is not okay is if you have duplicates of your x mapping to different values of y. This is not a function. If you were to look at the graph, a function might look like this. If you look up any value of x on this axis, you're only going to see one point that maps to it on the y-coordinate. So this is a function. This, however, is not a function. And the reason it isn't is if you look up this x value over here and you read what the y value is, you're actually getting two different y values. This is not a function because, for example, if this was a number 3 and this is 1 and this is 5, all of a sudden you've got 2 points that each start with 3. You got 3, 1 and you got 3, 5. So that's not a function. It is okay to have it going this way. If you have it going this way, yes, maybe this x value and this x value map to the same thing, right? Maybe they both map to the number 4. But if you put in 1, you're only going to get 4. And if you put in 3, you're only going to get 4. So this is still a function. That's okay. So if you're still confused, that is totally normal. We're going to do 4 more examples to hopefully clarify things a bit. So we have 4 graphs here, and we're asked to determine which ones are functions and which ones are not. So I'm just going to skip this middle one because it's not relevant to whether it's a function, and I find that it confuses students. So we're just going to look at this. Classify the following statements as true or false. For each input value, there's only one output. So we're looking up the x values. And we want to see if there's only one y value that pops out, or if there's actually two. So if you look at this one here, let's say we want to look up this x value. How many y values pop out? Just this one. Same with over here, just this one. Over here, yep, just this one. No matter what x value you pick here, only one y value is going to pop up if you read the graph. So over here, for each input value, there's only one output. That is true for graph A. It's also true for graph B. Take a look here. No matter what x value you try and read off the graph, it's only going to output one y value. So it's also true for B. But if you look at graph C and you read, for example, this x value, so -2, and you go to read your graph, you'll realize you can actually read two different points, one here and one here. That's actually true over here as well. One here and one here. I mean, if you read right here, then yeah, you're only going to get 1 point. But for a lot of these x values, if you try to read your graph, you're going to get two y values out. So for graph C, it's not true that there's only one output. There's two outputs for a lot of them. And if you look at graph D, you try and read this x value, for example, you're going to get two y values output. What about 6? If I want to read 6, there's actually two y values when I try and read my graph. And that's true of like lots of these points. It's not true for here. Right here, there's only one. But anyway, all these points have ruined it for that one. And there are multiple output values for at least some of the input values. So when we're trying to decide if this is a function, you only need this condition. If there are multiple outputs, then it's not a function. And if there's only one output value for every input value, that is a function. So if you're looking at a graph and you want to know very quickly whether it's a function or not, some people have devise what's called a vertical line test, which means basically if you want to test to see if a graph is a function, you just draw a bunch of vertical lines like this. And if you conclude that every vertical line that you draw is only going to hit the graph at one point, then it is a function. If I draw vertical lines here, no matter where I draw those vertical lines, they're only going to hit the graph at one point. So this is a function. If you draw vertical lines here, actually, some of the vertical lines hit it at more than one point. So that's not a function. And if you draw vertical lines here, some of the vertical lines hit at more than one point. So this is not a function. So the vertical line test is a way to quickly tell if a graph is a function or not a function. We can see some more examples on page 457, class example number 3. Determine which of the following are functions. So if we look at the set of ordered pairs, we cannot do a vertical line test on this because it's not a graph. So the telltale sign that it might not be a function is if you have duplicates of your x values. So let's just look at our x values here. Do we have any duplicates of our x values? Actually, yes. Right here, the number 6 is duplicated in our x values. So what this means is that if you input an x value of 6, it actually outputs two different values of y. And the moment that happens, this is not a function. Let's look over at this one. So again, we're looking at those duplicates, looking for duplicates of x values. It does not look like we have duplicates of x values. Now, some students might say, okay, but what if we have duplicates of y values? Like the number 3 is duplicated in the y. Doesn't matter if it's duplicated in the y. If it's not duplicated in the x, and we have all unique x values, then this is a function. So let's look at this mapping diagram. If we look at our x values over here and our y values over here, we're just looking to see if an x value actually maps to more than one y value, and it doesn't. Every x value only maps to one y value, so this is a function. If it looked like this, that would ruin it and it wouldn't be a function anymore because then the letter A would map to two different letters. So over here, we have a graph, and a graph means that we can apply the vertical line test. So let's see, if we draw vertical lines, does it hit the graph at more than one point? Actually, yes. If you draw this vertical line, it hits two different points. So this would be not a function. I almost missed this question because it was in words. The relation connecting the provinces and territories of Canada with their capital cities. So what you can imagine is if you, for example, have Alberta, that maps to Edmonton. And if you have BC, that maps to Victoria. So you can already see that every x value is unique and it only has one capital city. So this one would be a function. You're not going to see these very often. And the last two are graphs. So for the graph, to check if it's a function, the quickest way is to apply the vertical line test. If you draw a bunch of vertical lines, it looks like this one. These vertical lines are only ever going to hit one point on the graph. So this one is a function. This one over here, let's apply that vertical line test. Oh, wait a second. If you look at this line here, it actually hits it at 3 points, and this line hits it at 2 points. So the moment that happens, this is not a function.